Hi, my name is Andrew Way, and I wanted to showcase quickly the Wwise 101 material just to showcase my skills of implementing audio into middleware. I then go into the correct version, Cube and Cube I believe, into SoundBanks, into the correct platform, and I deleted all this so that when I load up Wwise, there are no sounds in the project and I can start to implement the sounds I wanted to. So firstly, what I wanted to do was I wanted to profile the game. So to do that, I run the instance of the Cube project. I'll go here where it's a bit quieter because you probably can hear the teleports. I then go into my Wwise project. I start the remote connections. That is my Mac. I connect this, and as you can see, there's a few error messages. This is just because this is a very early version, so I haven't got all the events created and so on, so there will be some error messages. So now that you've got the profile set, I go back into the game, and I want to capture this weapon. Now I've done that, I was going to quit, and as you can see that the events played and all of that kind of stuff. So I create a fire ice gem player event. So that's basically when the person shoots the ice gem, that event is created. So as you can see down the bottom left, first one over here, it's created this event with the same name so that the event is called properly. So I wanted to create my own assets, so I quickly went into Reaper and came up with something quickly. So I created that, I then saved it as a WAV file, I then import it into the Wwise project. I then want to go into SoundBank, and I created a main SoundBank. This is where all the events are going to be going into. I then dragged the newly created event into the SoundBank editor. I generated all. Okay, so for lesson 2, the first part was importing this audio file which played 2 parts. It was a whoosh and this kind of magic recharge sound effect. So as you can see here, under the staff recharge, got gem recharge magic and gem recharge whoosh. If I go into the sound effects, you can see that there's 2 parts to the sound. So the idea here was there was one audio file, but it's been referenced by 2 different sound objects. And in the whoosh, let's quickly go into designer view. And as you can see here, I've enabled the randomized pitch by a minimum and maximum offset of 200 cents. So there's a bit of variation when playing the sound effect. I then import the magic and the whoosh into the Fire Ice Gem player event, and as you can see there are specific delays. This is just because I wanted to match the animation on the screen, and for more randomization, under the gem drop I have these effects where you have these random containers which play different audio samples. If we go to the tail side, and quickly I change the play type to shuffle from standard. And inside each of the random containers, I added a randomizer of -200 and 200. And then what I did here for even more randomized sounds is I duplicated the sounds. So I had a gem head, so this is the initial impact, and then the tail. And then I create a new parent, a sequence container to contain both of the random containers. And as you can see there, I dragged the gem head random container first, and then the gem tail, so that when the action happens, it'll play the sequence container, it'll play the gem head, and then it'll play the gem tail randomly. But I also didn't like how it didn't sound very natural, so what I did was I created a Wwise silence asset and then placed it in between so that there's a slight pause in between the head and the tail end of the gems breaking. And additionally, kind of random, but for the staff, I wanted a whoosh. So whenever he attacks, you see the staff kind of whoosh from the right hand side to the left. Just a slight whoosh to fit the visuals. Okay, so for lesson 3 was a focus on the footsteps. So I went into the game syncs page and I created a new switch group called materials, and then 9 different switches for the different material types. So when the player is on the grass, you'll play the grass sound effects and so on. I then go into the audio view and I just import all of the footsteps. As you can see here, footsteps, But what I did is I implemented the folder, and I told that the main folder, Footsteps, was going to be a switch container. The subfolders were going to be random containers, and the audio files was going to be audio files. So when I clicked import, it did all the hard work for me. And switch container, random containers, and all the audio assets there. Okay, and after, what I did was I dragged each individual random container into the assigned objects. And as you can see, there are a few missing sound effects. So I haven't got metal, I haven't got grass, water, or wood. But to save the programmer's time later down the development cycle, is I gave them a placeholder sound effect of sounds I already have. Now that the Footsteps have the correct switches, I just go into the SoundBank layout. I then drag and drop the foot player event. But of course, what I should say is I dragged the switch group to the event called foot player, have then imported that event, click to generate all, and I have working footsteps. So when I go into the game, I have the sound effects. And as you can see, it seamlessly transitions to the tile sound. Okay, then next I wanted to create a health system. So what I did, I imported breathing and heartbeat sound effects, like so. So what I did first was I created a game sync, and under game parameters I created the player health. So the health is out of 100, so minimum value is 0, maximum is 100, and of course I want the player to be at 100 health, so it's set to 100. I then make sure the audio assets loop indefinitely, so for both of them, as you can see, the loop is turned on. I then go into the RTPC tab and I create y-axis for the voice low pass and the voice volume. So if I just increase this, and within the RTPC values, I created these graphs where this represents the player's health. So when the player health is between 50 and 100, no audio files are played, and then the less health he has, the more audio it becomes. To help with that, with the low pass, as you can hear here, it's very audible. The more health he has, it does get quieter, but you can also hear the low pass coming into effect. So then what I do next, in the game syncs page, I created a new state of the player life, and whether he's alive or defeated. So when he's alive to defeated, there's a 5-second transitional period. So if I go to the player health, let's just change the RTPC value to, let's do 16. Go to the state, I'll make sure he's alive. Let's just say he's died. I click died. As you can see, the heartbeat dies out, because obviously when a player's dead, you don't want his heartbeat and breathing playing continuously. So the second the character dies, the audio for heartbeat and the breathing will die out as well. Okay, so we are in the game. Unfortunately, I haven't got any sound effects for this red star rocket weapon type thing, because it wasn't covered in the material, but it's definitely something I want to add later down the line. But I just want to show you the health system. So if I just do a bit of damage to myself, as you can hear, I'm on 43 HP, and you can start to hear the heartbeat. I've done more damage to myself, the heartbeat continues. As you can hear, the heartbeat and the breathing is a lot more audible, and then I've killed myself. So the health system is working. Okay, so in lesson 4 was definitely a focus on kind of 3D sound and spatialization and kind of the positioning of audio. So for this, I imported the teleporter sound effect. So I made this portal sound in Reaper, so I used the Vital synth. I created a simple saw wave, and I just used an LFO to affect this filter, so it goes up and down to create that movement of the portal. So that was imported into Wwise. So I go onto the teleporter emitter sound. Under positioning, I go into position and orientation for the 3D spatialization sound. And then where it says attenuation is where I selected the object attenuation which we created. So I click on edit. You'll see here I have this graph. So when a person's 100 distance away, you can't hear anything, and as a player starts to get closer and closer, you'll hear that the emitter gets louder and louder. I also created a low pass filter. Okay, so on the bottom right, you'll see the cone attenuation option. I just lowered I decreased the angle and the low pass filter. So essentially what this means is when the portal emitter is facing the player, it's a lot brighter, but when the portal turns and rotates, if it's not facing the user, there's a slight low pass filter to simulate that. So if I play it here, you can see the dot, the center is the emitter, this red dot, this black dot is the player. It's in front of the portal, you can hear it, and as it goes slightly off, there's a slight low pass filter just to because of course if something is facing away from you, it's going to sound different to as if it was going to be facing towards you. So that's what the cone attenuation is doing. When I'm quite far, you can hear it, it's quite quiet. I get a bit closer, it becomes louder. If I look at it, you can see it gets a bit quieter when it faces away and louder when it faces me. And to showcase the teleport sound, if I go into it, you can hear that delay sound when I go through it. Next, I wanted to create 3D positioning for the gem drop sequence container. So if I go over there, if I just go to the gem drop sequence container, so I go into the positioning tab and select the object attenuation. And under 3D position, I change it from emitter to listen with automation. If I go into that, you'll have this view. And what I did here was created paths. So basically, the center is the person, and then I have here, you can see that I've created different paths, and as you can see, different paths deviate, because of course, if you drop something on the floor, they're gonna bounce in different places all the time. So for the Starfree charge, you have the magic and the whoosh. If you look at the animation, I'll just run it quickly, you'll see the staff is on the right hand side. So to accompany that graphics, I go here and you can see where the speaker and the panning is under the positioning tab. Click on edit and I just move the center point to the right and a bit forwards to simulate that the sounds are coming more from the right hand side to fit the gameplay. I also wanted the movement for the first whoosh, because if I go into the game again, as he first moves his stuff, it moves from right to center a little bit to the left. So I go into Wwise, I go into the gem staff whoosh, and under the 3D position, I just create a path going slightly from the right side, moves to the left, so it kind of follows the staff moving from right to left to create some more sense of movement. I then go into the layouts, SoundBank, and just generated all so that everything was working. And for lesson 5 was just to learn and understand the audio signal flow. And I didn't want to use the lesson 5 template because I wanted to keep my audio assets so it looks slightly different. But in here, as you can probably see, I have actor mixes. So if I go to the main character, I have these actor mixes called items, magic, and main character. So this is basically just to contain all in the information, because without that, under the default work unit, there'll be so many different sound sources going on, it might be quite hard to find what kind of sounds you were looking for, and they are color coordinated as well. So if I was later to go into the project and I wanted to add stuff for the main character, I can go into the main character actor mixer. Maybe I wanted to add another footstep, so I can go into the switch container, add another random container, and I have a new footstep working. So it's just a case of keeping things organized, have it color coordinated, all condensed so that it's easy to find as well. And as you can see, I've created a couple of little things underneath the master audio bus. So I have sound effects, environmental, and so on. So this is because later in the game, let's say if I add music and the user wanted to lower the sound effects, lower the volume, they can do it. And the next part is I wanted to add some sound effects. So for the portal emitter, I added a delay of a 1 tap quarter second. I also wanted to create some reverb zones. So that'll be different reverbs depending on where the player is and how big the room is around the player. So I create a new auxiliary bus in the environmental bus. And as you can see in the end corridor, I have a Wwise room verb. Okay, so now I created the reverb. I go to the main character, and as you can see here, if I just move this up, I have clicked on use game define auxiliary sense. So if I go into the game, if you listen to the footsteps in this room, it's quite subtle, but you should be able to hear a slight bit of reverb. And lesson 6 was a focus on the mixing, but there was a lot of musical elements which I didn't want to go into right now, so I'm just going to move on to lesson 7. This was to optimize the game. So within the share sets tab, if I go there, I created, under the conversion setting, I created a sound effects conversion setting. So I go into the conversion setting editor, and firstly I changed the format from PCM to Wwise. So the potential issue is that the game system would need to decompress the files to play, but it also means the file sizes are reduced a lot. As you can see here, the original size for this sound effect is 272 kilobytes, now it's 14.6. Next one is 437, now it's 20. As you can see, it's almost like a 90% reduction almost. Another way is if I go into project and project settings, under the Mac, which is I'm using, I lowered the volume threshold to -50 and the max voice instances to 40. It's just because, say if you're in a room full of enemies, you're taking damage, you're doing damage, you're jumping, you're shooting, you know, a lot of audio files are going to be playing. So if I lower the instances, it's going to be less CPU intensive because there's less things to process. Okay, so another example of optimizing the game is if I went into the Magic Actor mixer, and under the advanced settings I clicked on limit sound instances. So I did 25 globally, so when limit is reached, kill voice for the lowest priority, and priority is equal to discard oldest instance. Okay, so what Wwise is saying that I can't have more than 25 variations globally of the Magic Actor mixer. So that's basically all the gems breaking, the whoosh, the gem blast, and so on. And if it does reach it, it kills the oldest voice, which won't be the most important anyway, so it saves on CPU and all that processing power on other stuff. Okay, so that is basically the Wwise 101 example up to the 7 lessons. There's a lot more things to look at, which is different materials, monster sounds, pickup sounds, you know, launcher sounds, and so on. So there's a lot more things I can add to this, but the lessons showcase the early stages of the Wwise Cube game on how to implement sounds into the game, and hopefully you get a sense in that video of the stuff I've done. If you have any questions, please comment down below and I'll be happy to discuss about them. Thank you so much for watching, and I will see you in the next video. Take care now.